Alright folks, here we've got a slightly more complex calculation. Trying to bring together some of your knowledge across all the other calcs that we've done. So looking at the circuit diagram, it's a series parallel resistive network. What information do we have? Well, we've got a 30 volt supply with 2 amperes flowing in the entire circuit. Okay. The parallel part of the circuit is made up of 2 resistors. You'll see here each of them are the same resistance value. Okay, so each one is 10 ohms. So RP1 is 10 ohms, RP2 is 10 ohms. The series resistors, we have RS1 as unidentified and we have RS2 as identified as 5 ohms. Okay, so first thing we have to calculate is this series resistor RS1. Before we can calculate what this series resistor value is, we've got this parallel part of the network that we have to calculate. So we need to work out what this accumulated resistance of having these two 10 ohm resistors in parallel with each other, what that calculates out to. Okay, so RS1, we've got a few options. Option number 1, we can do the 1 over RP calculation, where we take 1 over RP1, which is 10 ohms, 1 over RP2, which is also 10 ohms, add them together, so 1/10 plus 1/10, 0.1 plus 0.1 equals 0.2. But remember, we're finding 1 over RP, so we need to take that 1 over here and move it over to above this 0.2. Okay, so we're moving it over. So we're now looking for RP. RP equals 1 divided by 0.2. 1 divided by 0.2 is 5 ohms. Okay, so that's option number 1, a 1 over RT calculation. Option number 2, we could do a product sum calculation. Because it's only 2 resistors, it's very straightforward, very quick. So we do the product of the 2 resistors, so that's 10 times 10, plus the sum of the 2 resistors, 10 plus 10. So that's 100 divided by 20. That gives us that same 5 ohms. Option number 3, well, both resistors, as we said at the start, are 10 ohms. They are the same value. So when they're the same value, we know that what we can do is we can take the value of one of these resistors and divide it by the number of parallel branches. Okay, so if that was 4 10 ohm resistors, then I would divide it by 4. So take 10 ohms and divide it by 4. But here it's only 2, so I'm going to take 10 ohms and I'm going to divide it by the number of branches. So 10 ohms divided by the number of branches, 10 divided by 2 gives us that same 5 ohms. Okay, so we now know that this parallel part of the network it's not popping up, has a 5 ohm resistance. So this here is effectively a 5 ohm resistor. Okay, looking at the circuit, we have a 30 volt supply and a 2 ampere load. Okay, using basic Ohm's law from this here, we can work out what the total resistance is for this circuit. So the total resistance is 15 ohms. Okay, so we know that this 5 ohm resistor plus this now 5 ohm resistance plus whatever RS1 is equals 15 ohms. So in order to find RS1, we need to take that 15 ohms for the accumulative resistance and subtract these values for the series part of the circuit. Okay, so RP and RS. So I take that total resistance of 15 ohms and I subtract the 5 ohms for RP that we just calculated, and I subtract the 5 ohms for RS2 that's in the diagram. So that leaves us with RS1 giving us a value of 5 ohms. Okay, so we've got a 5 ohm resistor here in RS1 as well. Okay. Now that we've done that, we then need to calculate the power. This time we're going to calculate the power through RP2. So one of these parallel resistors, so it's this resistor here. What is the power through this resistor? So a couple of options. Option number one, first and foremost, we need to find VP. So VP equals IT times RP. So IT is 2 amperes, RP for the entire parallel entire parallel resistive part of the network is 5 ohms. So that's 2 times 5. So that gives us 10 volts. Okay, so we have 10 volts sitting across this part of the network. Okay, so there's 10 volts across RP1, there's 10 volts across RP2. So we now need to work out the power through RP2. Well, we've got V squared over RP2. So P equals V squared over R. Yeah. So V squared, we've got that 10 volts. So it's 10 times 10 divided by the 10 ohms. Okay, so that gives us 10 watts. Other ways in which we could have done it? Well, if we know that here we have 2 amperes coming in, we could have looked at this 2 amperes and said, well, using Kirchhoff's current law, if these resistors are the same, then there has to be an equal amount of current traveling through each one of these resistors. So what I could have done is I could have used Kirchhoff's current law there and identified that it's 1 ampere flowing through RP1 and 1 ampere flowing through RP2. And at which point then I could have then carried out, that's not the same calculation, but I could have calculated power taking I squared times R. I squared, well, in this instance, the current flowing through here is 1 amp. So 1 ampere times 1 ampere is 1. And then times 10 would have given us the same 10 watts. Okay, so there's multiple options that we could utilize to calculate the current through each one of these branches. Okay, hope that helps.